Everybody, and welcome to today's lesson on mixtures for chemistry. This is part 5 of my chemistry tutorial, and in this part I hope to accomplish a general understanding within you guys of mixtures, which are very important substances within the world of chemistry. Now, I mentioned in the last part that mixtures are probably my weakest topic of chemistry, and indeed they are, mainly because the definition of a mixture can very well be ambiguous, and I'm going to talk about the ambiguity of such nomenclature at the end of today's lesson, so we can really accomplish a sense of limitations and sort of a boundary to which we can approach and should approach chemistry with. So I'm going to begin today with the standard definition of mixtures, which will be a physical blend of 2+ substances. In other words, a physical blend of more than one substance. And we're going to talk about substances too. In a little bit, I have that. We're going to talk about substances and what a substance really is. Maybe review that. And let's review that right now. Let's go to substances, and let's review that a substance is a material that can only be broken by chemical means, and that would be like water, for example. Water is a substance versus a mixture, which is going to be something that we can really break apart through physical means. So let me put a versus here. Mixture, which would be physical means. Now, you're probably wondering then, what is the proper definition of a mixture? Wow, a mixture, the hierarchy will go: an element will yield a compound, which can yield a substance, which will yield a mixture. Now let's discuss them, and let me bring mixture over because I kind of went overboard with that. Let me bring mixture over. Let's bring this entire thing over, rather. Now, let's talk a little bit about Let's talk for a little bit about what we're going to be accomplishing right now in talking about these type of compounds. So let's begin with the element, which is basically any substance on the periodic substance. I use the term lightly. Any mass on the periodic table. I put term by accident. Let's examine this. So, for example, carbon, lithium, chlorine, germanium. Yeah, all these types of substances can be defined as elements because they're said to be in the purest state. Let's put this down. The first thing that you can learn about the periodic table is they cannot be broken down. Let's put this down. Cannot be broken down into smaller matter. Well, at least we so decide they can be. These are the defining blocks of our universe. So I want you to use this term, this definition, very, very lightly, because in fact we can break down all these elements, but we're going to be worrying about that later. For the purpose of this, an element, well, there are exactly 114 elements on this table. This is actually a not updated table, the periodic table. There's a couple elements down here that we've recently found to exist, but and finding to exist means we've isolated this element and we found, okay, this is an element, this cannot be broken down any further. And so, but the problem with these guys are they are very, very unstable elements, which means they will break down into those materials we were talking about earlier. But don't concern yourselves with that. I just wanted to I wanted to ensure that you guys do not take this definition that it cannot be broken down to smaller matter very seriously. Just recognize into any distinguishable smaller matter. Let me put distinguishable. That is the word that will help us. Distinguishable. Okay. Now let's go down here, and let's say that an element will yield a compound, which is a chemical blend of 2+ elements Notice blend meaning a coming together, a sort of bond, I guess blend is the best way to say it. So we're gonna use this example NaCl, which is, believe it or not, table salt. So let me put table salt right there, just so you guys know that NaCl is indeed table salt. Now, as you can see, Na is right here. You probably can't see me do this in a different color. Na is right here. Chlorine is right here. Now, together, these two elements, which an element, let me put down another definition over here. The definition that I just found in my notes. Simplest form of matter. Simplest form of matter. I mean, I'll write this down. I'll just say it out loud. An element is the simplest form of matter that can exist under normal laboratory conditions. And these are, for example, the examples that I have listed down in my notes are oxygen, carbon, nitrogen, and hydrogen. Oxygen, carbon, nitrogen, and hydrogen. Now, these are all very important elements that can yield into different compounds. And a compound is a substance that can be separated into simpler substances only by chemical means. So it's a chemical blend of 2+ elements. And I gave you the example of NaCl, which is the coming together of the element sodium and the element chlorine to yield NaCl. And don't really concern yourselves yet with the nomenclature behind it. Just note that this compound will come together to make table salt. And interestingly enough, sodium and chlorine have very different properties when they're in elemental form versus compound form. And we're going to get into that, my friends, a little bit later as well. But just, I want to throw these things at you so you can keep them in the back of your head. So I'm going to change things up, and I'm going to start talking about substances next. And a substance is, well, a bunch of compounds that will come together. Compound and substance can be really interchanged. I just wanted to throw the word substance in there. Again, this nomenclature can be argued. But the final thing is physical blend. Because we cannot, if we could chemically blend these 2+ elements together, then they'd become a compound. They wouldn't be a mixture. Physical blend is a physical blend, mixture is a physical blend of 2+ elements. Nope, substances. Sorry about that. Took me a while to figure that out. But using this definition now, we can really start to figure this thing out. So I'm going to give you guys a very good example of lemonade. Let's try to define lemonade. Let's first figure out, is lemonade an element, compound, we're going to ignore substance, or mixture? Well, let's decide something. Can we see lemonade on the periodic table? Does lemonade show up on this periodic table? I'm going to save you the trouble of looking through every element. I'm going to tell you that lemonade indeed does not show up on the periodic table. So it is not an element. Next thing, is it a compound? Well, let's think about it. What does lemonade contain? Well, lemonade, inside it, lemonade has water. Lemonade has lemon juice. Lemonade has sugar. And we're going to stop right there, because upon realizing this, you realize that all the constituents of it, these are not elements either. I want you to show me where water is located on the periodic table. You can't find it. Neither can you find lemon juice, nor can you find sugar. Indeed, these are all compounds in themselves. Water is actually H2O. Lemon juice is actually, a blend of it is even more. Lemon juice itself is maybe even a mixture you can distinguish it as. Sugar is C6H12O6. Actually, it's C12H11O22. But I think I messed up that definition, but C12H11O22. I was looking back on that. I don't know if I did the sugar right. If I didn't, we'll just, ignore that, because I'm not really thinking more or less in terms of sugar. I'm thinking more or less in terms of lemonade. So as you can see, all these elements, hydrogen, H, definitely located. H is, well, we only have H. Indeed, H is located right here. Oxygen right here, carbon right here, but nowhere do I see sugar, nowhere do I see lemonade, nowhere do I see lemon juice. So therefore, lemonade has to be a mixture, which is a physical blend of two plus substances. And because of that, we know that we can separate lemonade into water. We can separate it into water. We can separate it into lemon juice. And for the record, if you don't know what H2O is, you might have heard it. If you don't know what it is, though, do not worry. We will go into that stuff. It's sugar. You know, all these substances will come together to form lemonade. All these substances, all these compounds will come together to form lemonade. I need to think very clearly when I talk about this kind of stuff, because I don't want to say that something's a substance or like a compound when it's really a mixture. So you can begin to see that the nomenclature behind here is really important, that we really specify what we mean when we say something's an element or something's a compound or a substance or so on and so forth. So now let's discuss mixtures in a little bit more detail before finally ending today's lesson off. So let's begin with the homogeneous and heterogeneous. These are two words that you probably have no idea what they mean. And that's okay. I didn't expect you to know what it means. If you knew what it meant, then you'd be teaching this class, not me. But homogeneous will be a well-distributed, uniform mixture. Now I'm coming up with this definition actually off the top of my head. It's not the standard IUPAC, which is the organization that governs world of chemistry. That is not their definition. Their definition will be a little bit different. I don't know it off the top of my head. I'm trying to define it in terms that... Out. Out. I'm busy, Priya. But heterogeneous, however, will be a ununiform mixture, and this will be some kind of mixture that when you take a sample of it, it won't be necessarily the same compound. A good example of this will be beach sand. I'm going to put beach sand over here, and I'm going to put milk over here. Let me put this in different colors, however, so we can distinguish it. I'm going to put milk over here. Now, again, we can say that milk nowhere appears in the periodic table. Neither does beach sand. However, these are mixtures, therefore, so we know they're mixtures because they are a physical blend of two plus substances. Compounds, rather. Two plus substances is actually the proper definition. Never mind. And so, we can separate these things, but more importantly, let's examine this. Let's say I have a beaker of milk. Let me draw milk in the characteristic white. You know, that's milk. And let's say I have a beaker of beach sand. Let me do that in this kind of color. Let me just dot it up over. Yeah. Dot. Let me put some different colors in there just to shake it up. Oh, yay. Okay, but when we take a certain sample of it, let's say we take this section of our milk. This section. Well, let's think about this. Will the milk still look like milk? Will it still have the same? Yes, it will. Just know that milk is milk, no matter where you go. The same type of milk will show up all the time, versus in a heterogeneous structure, such as beach sand, different portions that you take will have different components and different measures of components of each type of thing. One sand might have more sand than the other. One have more seashells, for example. You know, so basically what we can say is this is well distributed, and one part gets well distributed basically, and versus the other. Now, there are several methods available to us to separate mixtures. It's important that we know what a mixture is. It's more important that we can separate a mixture. So let's decide how we're going to separate mixtures. So we have several methods available to us. We have distillation available to us. We have by mass. We have sifting. We have several different methods. And distillation is basically, it's going to be heat the mixture, so only one substance will boil out, and boil means only one substance will turn from a solid to a gas. It will be excited enough, so one substance will turn to a solid to a gas, and then we all know this, when we have water and we heat it up to the boiling point of water, water boils into a gas and disappears. Well, same does with all the other elements. And by mass, we can use something called a centrifuge, which will separate it by mass, and sifting, which will be basically to go through it and pick everything out. It's ineffective because you really can't get a thorough thing, but at times it can be fast and it can be the easiest thing to do. Now, we know how to separate mixtures. How are we going to separate compounds? Well, we're going to have to use chemical means, and one chemical mean that I can give you off the top of my head is electrolysis. And that will be an example of another chemical means separating compounds where you throw electrons, and it really just disturbs the entire thing. It's a little bit more complicated than that. We'll talk about that a little bit later. But for lack of a better way of ending, we can just say right now that we have effectively described what mixtures are. Let's go back and let's review this one time before ending today's lecture. Now, a mixture is a physical blend of two plus substances, and it's disturbed by physical means versus a substance, which is a material that can only be broken by chemical means. Next, we discussed, let me move this. Let's discuss the nomenclature. We went from element to compound to substance to mixture. And an element is anything on the periodic table. A compound is a chemical blend of two plus elements. For example, table salt, which is NaCl, which can be broken down into Na, which appears right here, and Cl, which appears right there. Now, let's just see if I can... Okay. Next, we had homogeneous versus heterogeneous structures. And a homogeneous is a well-distributed, uniform mixture, such as milk, versus heterogeneous, which is an uneven, ununiform mixture, such as beach sand. And then we just discussed two methods of separating mixtures and several methods of separating mixtures and a method of separating compounds. So this has been a very, very thorough, I believe at least, it has been a thorough lesson. If you have any questions, be sure to check it out and see what you can do. I understand a little bit of our presentation went a little bit over the zoomed measure of the screen, over the crop measure of the screen, but that's okay. It shouldn't be too much of a problem for us to figure out. So yeah, this has been Phoenix Man 1015 from the Cave Tutorials, and in the next lesson, we should go over the next material in my chemistry notes. So until then, see you guys later.